Hey everyone, welcome to my channel. This will be first of many topics I will be discussing. And today's topic is on digital transformation, which is revolutionizing industries and helping them to provide value to customers. So today we'll see what and how they do to help industries get ahead of the game over their competitors. Today's audience of the topics are tailored to those who are trying to learn new ways of software development and help them understand the basics so that they can learn and grow. That includes the students who are in the early stages of professional development and help them understand how the IT industry has evolved. Also, to those who are in the industry for some time but trying to understand the latest practices. Myself, John Williams, and I've been with IT for over 13 years, helping clients do their digital transformation. I myself has evolved over the course of my tenure, and truth be told, we are definitely not doing the same as we were when I started my career. In today's video, we will try to learn the basics of various stages in software lifecycle and how the automation have helped us to move faster and safer. Also on how the cloud computing has helped every company become a tech company. So this is the first stage of software lifecycle where we write code based on the requirements of the business in a human readable form using syntax of a programming language. Here you can see a snippet which is to print a hello world to a system output, and it is written in Java language. So if you are the only developer and writing on a project, it would be okay to keep the code in your own machine and make changes when needed. But that's not the case with the bigger organizations where an application is being developed by multiple developers and multiple teams who are working on the same code. So if everyone has their own code maintained separately, it might result in a lot of issues when they come together to integrate the application. So this brings us to the need of certain repository where everyone can work on a base code and add changes and submit when they're ready. So GitHub is one of the provider of source control management, which is widely used by multiple organizations. And here, so the developers will actually create multiple branches on the source code, and once they are ready to check in, they can just send it for peer review. Next stage is to convert the code written in a language to a code which will be understood by a computer. So in build process, system or the compiler will try to find the dependencies and compile to a machine readable format. So for the previous program, it would be converted it into a .class file, so which is the bytecode and understood by a JVM. So this is a stage which helps the developers to validate if the code is compliant to the business requirements and satisfies those parameters. There are multiple levels of testing done for larger applications, and it is usually termed as a testing pyramid. So with unit testing, integration testing, system testing, all these testings can be done either in a manual or automated manner based on the company's maturity on where they are on the latest digital transformation. In this stage, we bundle the code and any other dependencies they have used into a single artifact, which is transferable and deployable in other systems. So for Java-based applications, so it's usually a jar file. So and there are advanced ways to packages using containers, which will be discussed later on a different topic. Now that we have the application ready and packaged, so we need to install or run the program so that it is served to the users, right? So this is usually done on a computing environment, so which has a CPU, memory, and the operating system. For example, so this Java application is to run, so we just have to give this command where it executes a jar file and then serves the application. Now we will see all these stages in action over a demo of Spring Boot Java application, which serves the API or the REST HTTP protocol. And this video does not talk about the Spring Boot development, but only emphasize the different stages in software lifecycle. Here you can see the code that is being written. So for a Java application, it's usually under source main and the package name. This is a Spring Boot application which exposes an API or REST protocol. And currently it exposes two endpoints, so one on the slash endpoint, which just gives back a response of hello world. Other endpoint, if you pass a parameter name, it just gives you back the hello with the name on. So this is the source code that I've talked to you about. The next step in the software lifecycle is the testing, so wherein we validate all the business requirements. So currently I have given two endpoints, and I'm just checking on that. So for slash endpoint, whether we are getting expected result as hello world, and then a second endpoint, whereas if I pass a name slash John on the API, it should return me an hello John. So if it passes these two test cases, then I can make sure that my existing Java application, which I written on top here, is valid. Let's move on to the build phase of the lifecycle, where we try to validate whether the code is of correct syntax or not. So this is a command that for Spring Boot application we have to use to check if the build is being success so that the compilation process is also success. In order to run the test, so we give Maven test, so which will run all the test cases that we have written in our application, and it will give you a good result of whether the test cases are passing or not. Now I have like three test cases in my suite, so it's all pass. Moving on to the next cycle, so wherein we package our application and make it ready for deploy. The package has given us a jar file, so which is the desired output for a Java application. Now, in order to run this, so we have to specify the command java-jar and the path of the actual application. This will serve this application or a particular port number, which is 8080, so which we'll be using to validate or whether the REST API is behaving as per the requirements or not. I am going to invoke the particular endpoint over the HTTP protocol for the port number 8080, which gives us the desired result of hello world. If I pass with an additional name on it, it should give me with a particular name on. We have seen different stages in software lifecycle, which so far has been done manually using different commands for a Java Spring Boot application. This is okay if we have just one application, which is not the case in a large organization having many different applications and could be written in different programming languages like Java, Node.js, or even Golang. We need these steps to be automated to reduce the errors and also to deliver faster. In the past, we had different teams handling these steps where dev team is responsible for creating new features, testing and packaging them, whereas ops team is responsible for maintaining infrastructure and promoting the packages to production. Ops team needs to ensure that package that they get from dev team is free of bugs or any vulnerabilities that may impact the users of the system. Ops team also needs to make sure there is very little disruption to users who are using the system. Since they don't have a readily available metric that can help understand correctness of the new features, it becomes an impediment and causes delay in rollout of new features. To remove this friction and help application evolve faster and provide value to users of the application comes DevOps process or framework. This bridges the gap between dev and ops team and unifies them to work as a single unit. Each stage defined here feeds the input to the next stage, making the process smoother. There are additional stages introduced when we enter the DevOps realm. Code and build takes care of building the new feature with certain coding standards agreed upon by the team to make sure it's of high quality. Test, release, and deploy takes care of there is no issues in new feature and also does not break the existing version of the application. These two are termed as CI and CD. Operate and monitor are termed as continuous monitoring to ensure application availability and error-free. Example of one such metric during CI phase is called a Sonar Cube metric. The bugs and vulnerability metrics ensure the code is free of bugs and vulnerability. And code smells ensures there are no deviations coding standards. And coverage ensures the code is unit tested and covers all the branches of the code. This is a quality gate for CI phase. There are other quality gates as we progress onto CD phases, which we'll explore on a different topic. Now that we have a way to develop features and application faster and release using DevOps framework, what about the hardware or infrastructure that it runs on? Organization usually maintains their own data center by investing on number of servers and databases. In case if we need a new machine to run applications on, then the team has to put in a request and wait for provisioning, which slows the application evolving faster. It also incurs a lot of manual operations that the IT team has to own. This gets addressed in a new way of computing, where organization does not need to set up infras on their own and incur the capital expenditure. They can start small or even start free and scale based on the usage of the system. Cloud computing is the delivery of services including servers, storage, database and networking over the internet to offer faster innovation. Provider maintains the infrastructure and it is shared by organizations who wants to use them. Elasticity of computing makes it widely adaptable so that we can provision and release resources based on the need. We also pay only for consumption of resources. They also offer a lot of managed services which helps us to develop application in a very short period of time. These are some of the tools that are used widely in the organizations who does the software development. For code, we know we use GitHub, GitLab, and for build, test, and deploy, we usually use Jenkins, which is an open source tool for a CI/CD platform. And for packaging an application, we use Docker containers, and to store those artifacts, we use something called Docker Hub. In case if there are more number of containers that we have in our application, we use something called Kubernetes to manage those Docker containers. And for provisioning of such resources, we use Ansible or Terraform scripts. Similar tool sets are available on the cloud platform like AWS or GCP. You can find the respective names of it given here. Thanks for watching the video and hope you liked it. Please do provide your feedbacks and comments. I also offer this as a bridge course for students either online or in person. You can find more details in the description. I'll see you again in the next video. Thank you.